Assalamualaikum warahmatullahi wabarakatuh and a good day for everyone. We are from Group 2. My name is Nur Imar Rifat bin Suhaimi and my partner is Muhammad Shakir bin Najmi and Muhammad Iqbal bin Murtaza. So, today we will explain to you about Lab 2 control principle and system, which is steady state representation. So first I will explain about the procedure that we must do in steady state representation lab. First of all, for part A, which is state space modeling technique, for an electrical system shown in figure 1, first we must find its state space representation, and second we must analyze its unit step output using MATLAB. For part B, conversion of state space to transfer function, in this part we must convert the state space representation of part A into transfer function and produce the unit step response of it.
For part A, the parameter from the figure 1 must be declared in the script, which is C1, C2, L and R equals to 1. Then apply matrix from the calculation, which is A, B, C and D. Then run the coding to get the matrix form in MATLAB, which is shown in command window. The reason why the D is 0 is because the calculation, the D does not exist. Normally the equation is y equal to Cx plus D. Therefore, the D has to declare it as 0. After obtaining the A, the student must plot the equation by using Simulink. In line 26, SS2TF used to return the Laplace transform function for continuous time system and Z transform transfer function for discrete time system. Figure 1 shows the graph of continuous time transfer function of G, while figure 2 is the feedback from G where waveform get longer transient response. For part B, student must convert the state space representation in part A into transfer function. The state space model is x equal to ax plus bu and y equal to cx plus du, same with the for part A. Then have to assume the initial condition equal to 0 for each term of Laplace transform to solve it and get the GS, which is the transfer function matrix. Based on MATLAB coding, the process is same with the calculation, where define the matrix of A, B, C and D. Then find the Si minus A and inverse matrix of it before we multiply it with C and B. Lastly, we simply use the simplify command that used to simplify the equation that received to get, which is s squared over s power of 3 plus 2 times s power of 2 plus s plus 1, which that define the manipulated input-output process of transfer function.
For the Simulink part, the first step is to select a unit integrator to obtain the ax plus bu. Then choose a gain block and set it to A. After that, add another gain for B and set it to B times U. For this part, it need to test with a unit step. Therefore, find a step function block which is used as a source. Set the source to 0 to make sure the starting point is start from 0 in the dot plot. For this operation, it needs to set ax plus bu, so it is very necessary to add an additional block. Next, add another gain block for C, which is y equal to cx. Finally, add scope block and run the Simulink and the both plot will come out. So this is the both plot from the Simulink block. But before run the Simulink, need to make sure all the parameter is in the workspace. The scope will show both plot after run it. Before that, set the stop time to 50 seconds to make it a smooth and stable signal. That's all from us. Thank you.